Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle.
In this video, we are going to create Vulkan instance. Welcome back. In this video, we are going to create Vulkan instance. So let's get started. First, we need to create a class and call it the device manager. Actually, this class is responsible for initializing all the necessary Vulkan objects. Okay, I'm going to add it to our project. Now let's prepare so we can start coding in this class. First of all, add Vulkan headers.hpp. It includes Vulkan headers. Then I need w underline object, w underline window, and w underline signal from Wolf. As I've mentioned before, to get things done faster, I use some codes from Wolf engine. Let's declare device manager class. This class has a public method called initialize. The input parameter of this function is a type of w underline present underline info, which presents all the necessary information about window. Just like the others, keep in mind that we are going to create static methods and members for this class, because this class will be created only once for the game, and then it is responsible for initializing and handling all graphic devices. First, create two private static members for this class. The first one needs to store a boolean value which presents whenever the device manager has released its resources. The second one is w underline present underline info, which is responsible to store window parameters. Now go to the device manager.cpp and let's implement these methods that we just declared in device manager header. Don't forget to add a static keyword here. Make sure to add it, because in C++, static methods cannot access non-static members. Okay, everything is compiled without any problem. Go back to the header of device manager. Here, we need another class called device. In fact, device manager should handle all instances of the device. Let's declare a constructor for device class. Add a release function to this device class. I want to prevent any chance that might result in copying this class. So I have to declare private constructor here. And also override this operator. Now let's declare two variables. One for storing the status of the release process, and the other one for storing name of this class. I'm going to put these functions inside pragma region. Then let's implement device methods inside another pragma region. Just make sure to set the default values for member variables. Now compile it again. Everything looks fine. We need to store all instances of graphic devices. Sometimes the target machine can have multiple GPUs. Therefore, we need to define it as a vector. So we declare it here as a vector of devices. Okay, include device manager header inside the scene header. We can remove Wolf's header because we already included that inside device manager header. Okay, here within initialize function of the scene, we should call device manager initialize and pass p present info as input parameter to this function. You can add pre-initialized codes here. After executing this line, your graphic devices will be created. So, if you would like to do something before creating graphic device, you can write your codes here. Let's check if this class is already released. So return 1, else call wObject release function. Also call device manager release, which is responsible for releasing all resources allocated by Vulkan. Let's compile it again and now build your project. Project is built successfully. In order to access the private members of device manager within device class, the device manager should be friend of device class. And we need another structure called device info, which contains information about Vulkan device. Let's add two public variables, one for storing device properties and the other for storing features of device. I need to declare device extensions here. The default extension which is needed for drawing is swap chain extension. Let's declare another method called release In order to release these variables, we need to declare another method. Delete the pointer and clear the vector. I need to declare some public methods in order to access the specific information of graphic device. The first one is responsible for returning the ID of graphic device. The second one is get device name, for getting the name of the graphics device. And the last one's job is to return the vendor ID of graphics device. I'm going to add to do here. Later on, I need to check if this pointer should be released in this or another class. Nice. Make sure to implement static devices. If your code is compiling under Windows platform, we should call co-initialize function. This function initializes the COM library on the current thread and identifies the concurrency model as a single thread apartment. The function is defined in obj base header. Make sure to check the return result. If the return value is equal to SOK, it means the function did its job successfully. If something unexpected happened after calling this function, it's better to terminate the program. Make a copy from present input parameter. Now we are going to enumerate all graphics devices. This function is responsible for enumerating GPU devices, initialize, and then store each of them in device manager class. In the release function, we are going to release all devices. First, release every shared pointer to device class. I'm going to use shared underline release, which is a macro function declared in Wolf that releases shared pointers safely. Make sure to call co-uninitialize. This function closes the COM library on the current thread, unloads all DLLs loaded by the thread, frees any other resources that the thread maintains, and forces all RPC connections on the thread to close. Okay, here we are going to start Vulkan programming in more detail. This section is very important because we are going to initialize the Vulkan framework. First, get the major, minor, and patch version of Vulkan SDK. Let's build our project and check the result of these functions. So set a breakpoint here. As you can see, the results are exactly the same as the current version of Vulkan SDK, which is 1.1.82. Now check the number of instance layers. Call VK enumerate instance layer properties. This is one of the Vulkan's function which is responsible for returning Vulkan instance layer properties. First, I'm just going to get the number of instance layer properties. Because we only need to get the number of instance layer properties, so pass null pointer to the last parameter. Again, call VK enumerate instance layer properties function, but this time pass a pointer to VK layer properties object. If the number of instance layer properties is equal to 0, then the function should return false. It's really better to log the problem into the console. As you can see, the number of instance layer properties on my target machine is 14, and we've got a valid pointer to VK layer properties. Now we need to get the number of extension properties. Same as before, first call VK enumerate instance extensions properties to get the number of extensions. And after you have got the number of extensions, if there's any valid extensions, get extensions properties. Because each extension is stored into a VK extension properties structure, then we have to create array of VK extension properties and pass it to the VK enumerate instance extensions properties in order to get all the available extensions. create an object from VK application info structure. The first member is S-type, which defines the type of this structure. In Vulkan, the type of every structure is defined via this member variable. If we don't set correct type of structure, then we will get runtime error. Set the application name. I'll give it packed Vulkan. Do the same for engine name. And finally, set the version of your application info. Now create a vector for storing the desired extension for Vulkan instance. Because we are going to render the Windows surface, we need to add vk underline khr underline surface underline extension underline name. Then based on your target build platform, set the specific surface extension name. The final step before creating Vulkan instance is to create an object from vk instance create info. First, set vk underline structure underline type underline instance underline create underline info to S-type. Then set null pointer to pnext, and finally set a pointer to Vulkan application info. If you want to enable any extension, you have to set it like this. Finally, it's safe to create Vulkan instance. Call vk create instance. The first parameter should be a pointer to vk instance create info, and the second parameter should be a pointer to function callback, and the final one is a pointer to vk instance object. Let's create vk underline instance in device class as a static member. Also, because we declared it as a static member, we need to implement it in the C++ file. Make sure to check the result of function and write some log to the output in case we have any unexpected error. Let's debug our project. All is fine. We've got 10 extensions. And finally, the Vulkan instance is created successfully. Thank you for watching this video. In the next video, we are going to create Vulkan device.